Today we want to go over just some of the basics of chemical reactions. We don't have time today to do this thoroughly or fully in depth, but just want to go over some of the basics of chemical reactions. So when we think about chemical reactions, one of the things we ought to think about is time scale. How rapidly or slowly do chemical reactions take place? And in terms of time scale, obviously we're measuring this from our vantage point, from our viewpoint, so on the human time scale, the way we experience time. Chemical reactions can happen very rapidly, very quickly, and also very slowly. From the lower end, just fractions of a second for a chemical reaction to take place, all the way up to the upper end, years and years and years and years and years before a chemical reaction fully takes place. And everything in between. So with chemical reactions, the time scale is from fractions of a second all the way up to lots of years for them to take place and everything in between. When we think about time scale, we also think reaction rates. What affects reaction rates? So in a chemical reaction, we need to think in terms of the frequency of the contact between the chemical components that are reacting. If it is very little contact, you have a slower rate. If they don't come into contact very often, that also slows it. If there's a great mixing of these things that react volatilely, you can have a very rapid reaction. So it's the frequency of contact between the interacting chemicals. The temperature plays a role. Higher temperature, lower temperature can affect not only the reaction but the time rate as well. And then the properties of the chemical that is interacting. Is it a solid, a liquid, or a gas? The shape it's in. All of these things play a part in reaction rates. Frequency, temperature, and properties. Then when we think about reaction rates, you can actually influence those rates. You can accelerate a reaction rate. This is called using a catalyst. A catalyst is introduced into that chemical reaction, which greatly speeds it up. And that's the catalyst's only job, is to come into this interaction between these chemicals and to speed up that reaction that would ordinarily take place over a slower period of time. You rapidly increase it. But you can also decrease reaction rates, and this is called using inhibitors. If you introduce an inhibitor into a chemical reaction, it slows it down. It keeps them from reacting as quickly. So you can affect reaction rates not only naturally and through ways that you're able to control temperature and what form it's in, things like this, but you can also introduce other chemicals, catalysts to accelerate and inhibitors to decelerate the reaction times of the chemical reaction. Now, chemical reactions can, when they occur, release heat, release light, electrons, ions. There's usually some form of product from this interaction, this chemical reaction that's taken place. Sometimes chemical reactions send the temperature in the opposite direction, but usually it's things like heat and light, electrons being traded or spun off, ions, radicals going off, things like this. And then finally, heat and other factors can influence chemical reactions and help break bonds. If you think in terms of breaking down carbon bonds, this is done obviously in the production of oil and related materials. You've got strong, stable carbon bonds that need to be broken down and split up. Heat is usually a thing that is primarily used to help break those bonds, divide those things up, and then sort them out to their various functions and purposes. And if you ever do any sort of research or study, it's very fascinating to look at an oil or a chemical plant and how they bring in the raw materials using heat and other pressure and things like this to break up the raw material that's brought in into various other materials, sifted out and sent other places and put to other uses. It's fascinating. But anyway, chemical reactions then, just a basic overview again, time scale from fractions of a second to years and years and years. Reaction rates are affected by the frequency of contact, the temperature at the point of their mixing and their contact, and then the properties, solid, liquid, gas, the shape of it, these sorts of things. Reaction rates can be accelerated with catalysts, decreased with inhibitors. Chemical reactions produce things often like heat, light, spinning off electrons, ions, things like this, and heat and other factors influence chemical reactions and help to break bonds.
If you need a study guide, click the book at the bottom of the page. If you want more free test videos, subscribe to us on YouTube. If you just want to keep watching, click the next video.